I am Radhakrishna, mathematics teacher. So, our topic is definite integration. This is 6th lecture, 7th lecture. Let us first continue some problems and then we will start some new subtopic. Evaluate integral 0 to 1 tx plus 1 minus x whole power n dx, and hence show that integral 0 to 1 x power k into 1 minus x whole power n minus k is equal to 1 by n c k into n plus 1. Here along with x, t is also there. What is t? It is a parameter independent of x. Then taking t as a parameter independent of x, how to integrate this? This is in the form of ax plus b whole power n. We can write it as integral 0 to 1, write this in the form of ax plus b. We can write 1 plus t minus 1 into x whole power n dx. T minus 1 is independent of x, so just like constant. What is the integral now? Integral of ax plus b whole power n is ax plus b whole power n plus 1 by n plus 1, and we have to divide by a. So this is 1 plus t minus 1 into x power n plus 1 by n plus 1, and then we have to divide by derivative of 1 plus t minus 1 into x, that is t minus 1. Now substitute the limits 0 and 1. Substituting the upper limit, we will get 1 plus t minus 1 whole power n plus 1 means t power n plus 1. And denominator is constant, so write it as it is, n plus 1 into t minus 1. We have substituted upper limit. Now minus substitute lower limit. Substituting x is equal to 0, we will get 1 plus 0 whole power n plus 1, that is 1. So this is the value of this integral. If you want, you can write it as a sum of a GP. See, t power n plus 1 minus 1 by t minus 1 is nothing but sum of a GP. We can write 1 by n plus 1 into, what is that GP? Sum of a GP of n terms is a into r power n minus 1 by r minus 1. So this is the sum of a GP with first term 1 and common ratio t, and number of terms is n plus 1. So the GP will be 1 plus t square plus and so on up to t power n. Okay, so the first part is over. We have evaluated the integral. Now using this result, we have to prove that integral 0 to 1 x power k into 1 minus x whole power n minus k dx is equal to 1 by n c k into n plus 1. Now for proving the second part, let us find this different integral in a different way. I will write the result here. Integral 0 to 1 tx plus 1 minus x whole power n dx is equal to 1 by n plus 1 into 1 plus t square and so on t power n plus 1, t power n. This is what we have proved. Now I am going to find the same integral in a different way. We can write integral 0 to 1 tx plus 1 minus x whole power n. I will first expand this by binomial theorem. All of you know that x plus y whole power n is, I hope all of you are aware of the basic binomial theorem. The expansion of x plus y whole power n is sigma nck into x power n minus k into y power k, where k varies from 0 to n. Okay, or if you interchange x and y, you can also write it as nck into x power k into y power n minus k. Both are correct. So I will write this as integral 0 to 1 nck into tx whole power k into 1 minus x whole power n minus k dx, but sigma should be there. Integral 0 to 1 sigma of this expansion is this, k varies from 0 to n. Okay. Now this integration is with respect to x. Okay, so we can take out the sigma, we can write it as sigma k varies from 0 to n, integral 0 to 1, and also since we are integrating with respect to x and t is independent of x, we can take out t, we can write t power k here, t power k into integral 0 to 1 nck into x power k into 1 minus x whole power n minus k dx. Okay, so this asked integral is nothing but nck is also constant, we can take it out. Integral 0 to 1 x power k into 1 minus x whole power n minus k into nck is the coefficient of t power k. Coefficient of t power k is equal to integral 0 to 1 nck into x power k into 1 minus x whole power n minus k. Okay, you can expand this sum as sum of some different integrals. For k is equal to 0, 1 integral, for k is equal to 2, 1 integral, like that we can expand it as a sum of some integrals. The coefficient of t power k is this integral. It is equal to, what is the coefficient of t power k in this integral? 1 by n plus 1 is the coefficient of every term there. So coefficient of t power k in this, according to this, will be 1 by n plus 1. Now nck is constant independent of x, so dividing both sides by nck we get integral 0 to 1 nck into, integral 0 to 1 x power k into 1 minus x whole power n minus k dx is equal to 1 by n plus 1 into nck. Okay. Now, for example, we have a question, integral 0 to 1 x power 5 into 1 minus x whole power 7. Then immediately you take k is equal to 5, then n will be 12. Then what will be this answer? 1 by 13 into, what is nck? N is 13, n is 12, so it is 12c5. The value of this integral is 1 by 13 into 12C5. In this way, we can use this as a formula. So, all of you take this as a formula. Next, second question, show that integral 0 to infinity dx by 1 plus x power 4 is equal to integral 0 to infinity x square by 1 plus x square dx is equal to pi by 2 root 2. Let us take this. Remember, whenever one of the limits is infinity, we can try the substitution x is equal to 1 by t, when one of the limits is infinity. So, let us substitute x is equal to 1 by t, then dx is equal to minus 1 by t square dt. Then what happens to this integral? What are the new limits? If x tends to 0 plus, t tends to infinity, because t is equal to 1 by x. If x tends to 0 plus, t tends to infinity. So, lower limit is infinity. If x tends to infinity, then t tends to 0, 1 by infinity tends to 0. Now, dx is minus 1 by t square dt by denominator is 1 plus 1 by t power 4. Now, interchange the limits and remove this minus sign. You will get integral 0 to infinity, simplified, you will get t square by 1 plus t power 4 dt. Now, we can write this integral as integral 0 to infinity x square by 1 plus x power 4. Without changing the limits, without changing the function, we can replace t by x. That is the property of definite integral. Now, let this be I, adding this integral and this integral, adding 1 and 2. I plus I2i is equal to integral 0 to infinity x square plus 1 by x power 4 plus 1. Okay. How to integrate it now? Divide numerator and denominator by x square. Numerator becomes 1 plus 1 by x square, denominator becomes x square plus 1 by x square. Now, numerator is the derivative of x minus 1 by x. So, put x minus 1 by x is equal to t. T is already used, so it is better to substitute it as z. Then 1 plus 1 by x square into dx is equal to dz. Now, what are the new limits? If x is 0 plus, this will be 0 minus infinity. 0 minus infinity is minus infinity. So, new lower limit is minus infinity. If x is infinity, it is infinity minus 0. It is infinity. Numerator is dz. And what is the denominator? We can write x square plus 1 by x square as x minus 1 by x whole square plus 2. That means z square plus 2. What is the integral now? Integral 1 by x square plus a square is 1 by a tan inverse x by a. No? So, 1 by root 2 tan inverse z by root 2 and substitute the limits minus infinity and plus infinity. 1 by root 2 into, if you substitute infinity, tan inverse infinity is pi by 2, minus, if you substitute minus infinity, tan inverse minus infinity is minus pi by 2. So, minus of minus is plus. Then we are getting pi by root 2, but this is 2i. So, I is equal to pi by 2 root 2, it is proved. Let us proceed to next question. Let alpha be a real number such that, then show that there is no positive function f of x such that integral 0 to 1 f of x dx is equal to 1, integral 0 to 1 x f of x dx is equal to alpha, integral 0 to 1 x square f of x dx is equal to alpha square. Here x is not printed. To prove this, let us combine these three integrals as 1 plus alpha square minus 2 alpha. 1 plus alpha square minus 2 alpha is alpha minus 1 whole square, is it not? Now, combining first and third, or let us multiply this by 2 alpha, this by alpha square, and this is I1, I2, I3. So, what I am doing is 2 alpha I2 alpha square I1 plus I3 minus 2 alpha I2. I am multiplying this by alpha square and this by 2 alpha, and this plus this minus this will be 0. What is this? Alpha square into I1 is alpha square plus I3 is alpha square minus 2 alpha I2 is minus 2 alpha square. It is 0. Now, what is this alpha square I1? Integral 0 to 1 alpha square f of x dx. Second is I3. I3 is integral 0 to 1 x square f of x dx minus 2 alpha I2. This multiplied by 2 alpha will be integral 0 to 1 2 alpha x f of x dx is equal to 0. Then, since limits are same and f of x is common, we can write it as integral 0 to 1, what is this, after taking f of x common, alpha square plus x square minus 2 alpha x will be x minus alpha whole square. Integral 0 to 1 x minus alpha whole square into f of x is equal to 0. Now, x minus alpha whole square is a continuous function. Okay. If this integral is 0, here it should be there is no positive continuous function. Show that there is no positive continuous function f of x such that, suppose f of x is continuous and we know that x minus of alpha whole square is continuous. Then this is a continuous function. Suppose if f of x is positive, then this whole function is positive. Integral 0 to 1 f of x dx cannot be 0. If the integral is 0, then definitely this curve has to intersect the x-axis, and some curve will be below the x-axis, some curve will be above the x-axis. Then only you can get the definite integral as 0. Therefore, there does not exist any positive function positive continuous function f of x satisfying all the three conditions. Next question. Now we are going to discuss the subtopic definite integral as the limit of a sum. Let us consider the definite integral a to b integral f of x dx, and all of you know that it is nothing but summation of the values of the function. Now here we are going to see what kind of summation it is. I have divided the interval a to b into n equal parts. This is the curve y is equal to f of x, and now I want to add all values of f of x in this interval. Divide this interval into n equal parts. Then what is the length of each part, means each width. There are many strips now. Width of each strip will be b minus a divided by n. Let us denote it by h. So this difference is h. Now in this integration, what we are finding, you can understand very easily. First, take this first strip. I want this area. If I want this area, what I will do is, I will take the first height. What is the first height? F of a. And at the top, from the topmost point, you draw a horizontal line. Then this first strip is a rectangle. What is the area of this rectangle? Area of this rectangle is f of a into h. I will write it h into f of a plus. Now I will come to second step. In the second step, what is the height? This width is h now. So x coordinate of this point is a plus h. So this height will be f of a plus h. Then take a horizontal line like this, you will get a rectangle. Then what is this area? It is f of a plus h. This height is f of a plus h into h. That will be h into f of a plus h. Similarly, the next area of the next rectangle will be h into, what is the x coordinate of the third point? It is a plus 2h. So h into f of a plus 2h. In this way, till what, last but one point if you take, what is the height? This height will be f of a plus n minus 1 into h. Is it not? Then the last area of the last strip is h into f of a plus n minus 1 into h. So by adding these areas, you are getting the total area approximately. approximately, because here this is not actually a rectangle, some area is there above this rectangle, that is ignored. So ignoring all these areas, we are getting the approximate value of this area as this. This is how we add the values of the function. Now we can write this definite integral is approximately equal to this. Now suppose n tends to infinity. If n tends to infinity, what happens? This ordinate and this ordinate are very close, very close. Then what happens? This area which is ignored is negligible. Then this sum will be exactly equal to this integral. So how can you take n tends to infinity? By applying limit n tends to infinity. So here if you take limit n tends to infinity, then this sum will be equal to this definite integral. Okay. And another method is, I will start from second ordinate. If I start from second ordinate, first I will get height f of a plus h. Then at this top point I will draw a horizontal line like this. Then the first rectangle, area of the first rectangle will be f of a plus h into h. Here I am getting some extra area than the actual area, is it not? Plus, in the same way, if you take second ordinate and multiply by h, I will get this rectangle. What is the area of that rectangle? H into f of a plus 2h, and so on. If you add the last area like this, by taking last ordinate is what? F of a plus nh. This last ordinate is f of a plus nh, or it is nothing but f of b. See, cross multiplying by n, you will get nh is equal to b minus a. So a plus nh is nothing but b. Now till this sum continues till f of a plus nh into h, then you will get the approximate value of the area, but in this case you are getting some extra area. You understood from the diagram? In this method I am getting something less than this. In this method I am getting something extra. But when n tends to infinity, both will be same, because they are very close. When the two ordinates are very close, that is negligible. Okay. So we can write this definite integral as this sum or this sum. Now the same thing, limit as integral a to b f of x dx is equal to limit as n tends to infinity. I have taken h common. If I take h common, in the second method I got this, the same thing is here, h into f of a plus h plus f of a plus 2h plus and so on, f of a plus nh, where nh is b minus a, or integral a to b f of x dx is equal to limit as h tends to infinity, limit as n tends to infinity, h into f of a plus h plus and so on up to f of a plus n minus 1 into h. Okay. But in the first one, even if you start from f of a, there is no problem, because when we are adding infinite number of ordinates, okay, even if you add first ordinate and last ordinate and multiply by h, there is no problem, because the definite integral is nothing but limiting value of the sum. Okay. So even if you start from f of a here, or even if you end with f of b here, there is no problem. Where h is and b minus a by n. We can write this sum in the form of sigma. Integral a to b f of x dx is equal to limit n tends to infinity h into, how can we write this sum? Write the general term f of a plus rh. R varies from 1 to n. Sigma f of a plus rh, R varies from 1 to n. In the second method, R varies from 0 to n minus 1. R varies from 0 to n minus 1 in the second method. Now, we can find out the value of a definite integral by expressing as a limit of a sum like this. In this result, if you take a is equal to 0 and b is equal to 1, then h will be 1 by n. H is b minus a by n now. If a is 0, b is 1, h will be 1 by n. Then what happens to this result? You will get integral 0 to 1 f of x dx. Dx is missing. Dx is equal to integral 0 to 1 f of x dx is equal to limit as n tends to infinity 1 by n sigma f of r by n. See, h is r by n, a is 0, then it becomes f of r by n, h is 1 by n. So, this result will be limit n tends to infinity 1 by n sigma f of r by n. In the first method, r varies from 1 to n. In the second method, r varies from 0 to n minus 1. Okay. Now, using this formula, we can find out the limit of a sum by expressing as a definite integral. Okay. Now, using this formula, if you want to calculate the limits by using definite integration, we have to follow a working rule. What is the working rule? Suppose you have the question limit as n tends to infinity of some f of r. Some series is given, sum of a series in terms of n is given. Then step 1, write the sum as summation of some general term, sigma tr, where tr is the general term of the series, and express the series in the form limit n tends to infinity 1 by n sigma f of r by n by adjusting the terms. Okay. So, in the formula, after getting the question like this, replace sigma by integral r by n by x, then you will get f of x, and replace 1 by n by dx. You should write dx after f of x only. So, replace 1 by n by dx. Then you will get this integral, this limit as a definite integral. Okay. Replace sigma by integral r by n by x and 1 by n by dx. After that, we need the limits of the definite integral. The limits in this result are 0 to 1, but they may not be 0 to 1 always. Here r by n has become x. We have replaced r by n by x. So, limits of x are nothing but limits of r by n. Here r varies from 1 to n. If r varies from 1 to n, r by n varies from 1 by n to n by n. And what is the limit of 1 by n as n tends to infinity? 0. That is the lower limit of x. What is the upper limit? N by n. N by n is 1. Similarly, if you look at this, r by n has become x. So, limits of the integral are nothing but limits of r by n. What are the limits of r? Here r varies from 0 to n minus 1 in the second integral. dividing by n, r by n varies from 0 by n to n minus 1 by n. 0 by n is 0, n minus 1 by n is 1 minus 1 by n. When n tends to infinity, 1 by n tends to 0. So, the limits of the integral will be 0 to 1. So, first step is writing the general term and writing sigma. Second term is taking 1 by n common, separating 1 by n, write it outside sigma, and express it is in the form of, after separating 1 by n, remaining should be definitely in terms of r by n. So, we can write it as f of r by n. Then replace sigma by integral, replace r by n by x, replace 1 by n by dx. You will get the integral. Then for finding the limits of the integral, we have to divide the limits of r by n and take limit n tends to infinity. You will get the limits of x. Then evaluate the different integral, and the obtained value will be the sum of the series. Now let us solve some questions. First question: evaluate the integrals by expressing as the limit of a sum. We have to find out this integral not by direct integration, by expressing it as a limit of a sum. We know how to integrate this, and we can calculate the value within seconds. Integral of x square x cube is x power 4 by 4. Substituting the limits, you will get the answer 1 by 4. But we should not integrate. We have to express it as a limit, then calculate the limit and get the integral. Here we have to use the formula integral a to b f of x dx is equal to limit n tends to infinity h into sigma f of a plus f of a plus RH. R varies from 0 to n minus 1, or we can write 0 to n also, there is no problem. This is the first result we have discussed today. See, using this summation, we got the definite integral as the sum like this. Either you can write like this or you can write like this. In both the cases, you can take 0 to n also. So, coming to this question, write limit n tends to infinity h into sigma f of x is x cube. So, what is f of a plus RH? Here a is 0, b is 1, n is n only. Then what is h? H will be 1 by n. That is why if n tends to 0, if n tends to infinity, h tends to 0. A is 0, so it is f of RH. If f of x is x cube, f of RH is r cube h cube. R varies from 0 to n minus 1, I will write 0 to n, no problem. Now take out h cube, limit n tends to infinity, sigma r cube into h power 4 can be written as 1 by n power 4 using this. And r varies from 0 to n, or I will write 1 to n, 0 to n, or 0 to n minus 1, anything is okay, because it is limiting value. Now I will write 0 to n, then what will I get? Limit as n tends to infinity, this is 0 cube plus 1 cube plus 2 cube plus up to n cube, it is n square into n plus 1 whole square by 4. All of you know the formula for sum of the cubes of the first 10 natural numbers, divided by n power 4. Then n square cancels, you will get limit as n tends to infinity n plus 1 by n whole square by 4. How much? This limit is 1. So, answer is 1 by 4. So, we got the actual value of the integral by finding the limit of a sum. Similarly, let us take the next question. Integral a to b e power x dx. We have to find this integral by expressing as the limit of a sum. As per our formula, we can write as limit n tends to infinity h into sigma r varies from 1 to n or 0 to n, whatever you want, into f of a plus rh means what? E power a plus rh. Okay. Now, this is e power a into e power rh. We can take out e power a because r is the variable. Since a is independent of r, we can take out a power a. E power a into limit as n tends to infinity h into sigma e power rh, r varies from 1 to n. Now, if you expand, you will get a GP, e power h plus e power 2h plus e power 3h and so on, e power nh. So, e power a into limit as n tends to infinity. What is the sum of this GP? H into, this is, if you want you can write expansion, e power h plus e power 2h plus e power 3h plus and so on, e power nh. What is the sum of this GP? E power a into limit as n tends to infinity h into first term into e power all of you know the formula for sum of a GP, a into r power n minus 1 by r minus 1. Here r is e power h, r power n is e power nh. E power nh minus 1 by e power h minus 1. Now, if n tends to infinity, h tends to 0 because h is nothing but b minus a by n. A and b are constants. If n tends to infinity, h tends to 0. So, I will write here h tends to 0. And now, if you write this h in the denominator, like this is the standard limit. Limit of e power h minus 1 by h when h tends to 0 is 1. So, this will be 1. If this is 1, what is the remaining? E power a into this is e power 0 into e power, what is nh? nh will be b minus a minus 1. Taking e power a inside, e power 0 is 1, taking e power a inside, you will get e power b minus e power a. And you know that this definite integral is e power b minus e power a. So this is the method of finding the definite integral using the limit of a sum. Here we have not used the formula of integration anywhere. By expressing as the limit of a sum, we calculated the value of the definite integral. Now next question, find the sum of the series as n tends to infinity. Sum of n terms is given, we have to find the sum of the n terms where n tends to infinity. This is nothing but limit n tends to infinity of this sum. This is the given question. To find this limit, let us follow the working rule. What is the working rule? Let us see. Working rule is, first express the sum as sigma TR, where TR is the general term. What is the general term of the series? Numerator is same. In denominator, the changing number is here. 1 square, 2 square, 3 square. There you take r square. So you can write sigma of n by n square plus r square, general term. What are the limits of r? R varies from 1 to n. In the first term r is 1, in the last term r is n. So r varies from 1 to n. Write limit as it is. What is the second step? Second step, express the series in the form of limit as n tends to infinity 1 by n sigma f of r by n. So we have to take out 1 by n. How to get 1 by n outside sigma? Taking r square common from the denominator. If you take r square common from the denominator, n square common from the denominator, 1n cancels. Then it becomes limit n tends to infinity 1 by n sigma r varies from 1 to n. What happens? After taking n square common from the denominator, 1n cancels, another 1 by n is here. It will be 1 by 1 plus r square by n square, that is r by n whole square. Now it is exactly in the form of limit n tends to infinity 1 by n sigma f of r by n. Now what is the next step? We have to convert this into a definite integral. What is the working rule? Replace sigma by integral. Replace r by n by x. Then the function will be, if this is f of r by n, f of x will be 1 by 1 plus x square, and in place of 1 by n we have to write dx. Now we have to get the limits of the integral. Here limits of the integral are nothing but limits of x. X is nothing but r by n. R varies from 1 to n. R varies from 1 to n. Then r by n varies from 1 by n to n by n. 1 by n is 0. N by n is 1. So the limits of the integral will be 0 to 1. Now what is the integral? Integral of 1 by 1 plus x square, tan inverse x. Now substitute the limits. Substituting the upper limit 1, we will get tan inverse 1 is equal to pi by 4. Substituting 0, it is 0. So the value of this limit is pi by 4 when n tends to infinity. Next question, find the sum of the series as n tends to infinity, or show that the sum of the series as n tends to infinity is log 3. Let us write the question in the form of a limit. Limit n tends to infinity 1 by n plus 1 by n plus 1 plus 1 by n plus 2 and so on 1 by 3n. This is the given question. Follow the procedure. First write the general term of the series. First term is 1 by n plus 0, next is 1 by n plus 1, 1 by n plus 2, 1 by n plus 3, last term is 1 by n plus 2n. Every term is in the form of 1 by n plus r. So write the general term as 1 by n plus r, then you write sigma. What are the limits of r? In the first term r is 0, in the last term r is 2n. Now write limit n tends to infinity. What is the next step in the working rule? We have to get 1 by n before sigma. Taking n common from the denominator, limit n tends to infinity, we will get 1 by n sigma 1 by 1 plus r by n. R varies from 0 to 2n. What is the next step in the working rule? Replace integral by sigma, replace r by n by x, we will get the function 1 by 1 plus x, replace 1 by n by dx. Then to get the limits of x, divide the limits of r by n, then you will get 0 by n to 2n by n. The limits will be 0 to 2. So the value of this limit is nothing but this definite integral. Now calculate the value of this definite integral. Integral 1 by 1 plus x is log 1 plus x between limits 0 and 2. Substituting 2, you will get log 3. Substituting 0, you will get log 1, 0. So answer is log 3. Next question. Limit n tends to infinity, a sum of a series is given. In the series, what is the general term? General term of the series is n square by n square plus r square power 3 by 2. Is it not? And then take sigma. Limit n tends to infinity. What are the limits of r? In the first term r is 1. In the last term r is n minus 1. Now what is the next step? We have to get 1 by n here. Take n square common from the square root, from the bracket in the denominator. You will get sigma n square by, if n square comes out, it becomes n square whole power 3 by 2, that is n cube, into, you will get 1 plus r square by n square whole power 3 by 2. R varies from 1 to n minus 1. N square by n cube is 1 by n. Limit n tends to infinity, 1 by n sigma, r varies from 1 to n minus 1, 1 by 1 plus r square by n square, or r by n whole square whole power 3 by 2. What is the next step? Replace integral sigma by integral r by n by x. Then what will be the function? 1 by 1 plus x square whole power 3 by 2 dx. Now limits of x, divide the limits of r by n, 1 by n, lower limit of r is 1, dividing by n, 1 by n tends to 0. Upper limit by n means 1 minus 1 by n. What is the upper limit? 1. How to calculate this integral? You know that standard substitution for 1 plus x square power 3 by 2 is x is equal to tan theta. Put x is equal to tan theta. Dx is equal to secant square theta d theta. What are the new limits? If x is 0, theta is 0. If x is 1, tan theta is 1 means theta is pi by 4. So, new limits will be 0 to pi by 4, 1 by 1 plus tan square theta whole power 3 by 2 means secant cube theta into dx is secant square theta. Then what is it? 1 by secant theta is remaining, that is cos theta. 1 by secant theta, that is cos theta. You know how to calculate this integral. Integral of cos theta is sin theta, and calculate the limit. We will proceed to next question. In the next question, I will write direct steps. First term can be written as root over n square minus 0 square. See, all terms are in the form of 1 by root over n square minus something whole square. So, I am writing this as 1 by root over n square minus 0 square. Last term can be written as 1 by root over n square minus n minus 1 whole square. Now, this is limit n tends to infinity sigma 1 by root over n square minus r square. R varies from what? 0 to n minus 1. Now, we want 1 by n before sigma. So, taking n square common from the square root, you will get it like this. Then convert into definite integral, you will get integral 0 to 1, 1 by root over 1 minus x square. Write the formula and calculate, you will get the answer pi by 2. Okay. Next question, limit n tends to infinity 1 square plus 2 square plus 3 square and so on up to n square by n cube. First, you write general term r square by n cube. Is it not? And r varies from 1 to, in the last term, what is r? Last term can be written as 3n whole square. So, upper limit of r is 3n. Now, what is the next step? We need 1 by n before sigma. So, separate 1 by n. One by n sigma, r square by n square is r by n whole square. R varies from 1 to 3n. Convert into definite integral. Integral r by n whole square becomes x square then limits of r, limits of x, divide r, limits of r by n, 1 by n, 0, lower limit, upper limit by n is 3, so upper limit is 3. What is the integral now? Integral 0 to 3 x square dx. Integral x square is x cube by 3, limit 0 to 3. You will get the answer 9. Next, same model. If you convert this into different integral and calculate this, you will get 1 by m plus 1. All of you need to remember this as a formula. But while converting into different integral, you will get it like this. Converting to different integral, it will become this. Its integral is x power m plus 1 by m plus 1, and substituting limits will get 1 by m plus 1. But this different integral can be evaluated only when m is positive, because its integral is x power m plus 1 by m plus 1. Then you will substitute limits. But if m plus 1 is negative, you cannot substitute 0. That's why m should be greater than minus 1. This is the necessary condition for applying this as a formula. Okay. So all of you remember this formula, very, very useful and important. For example, limit as n tends to infinity, there is a question, root 1 plus root 2 plus root 3 plus and so on, root n by n root n. Then directly taking m is equal to 1 by 2, this integral will be 1 by m plus 1 means 1 by 1 by 2 plus 1, 2 by 3. This limit is 2 by 3. Next question. In all the previous questions, we have calculated the limits of sums, but this is a product. We can find the limit of a product by using the same method, but first we have to express it as a sum. You can write that product as n plus 1 into n plus 2 into n plus 3 and so on, n plus n by n power n whole power 1 by n. Okay. Now you write this n power n as n into n into n into and so on, divide each bracket. Write it as by n and so on n times. Now if you assume that the limit is k, by applying logarithms, LHS becomes limit as n tends to infinity log of this power 1 by n is 1 by n into log of this product. Which product? First factor is n plus 1 by n means 1 plus 1 by n. Next is 1 plus 2 by n into 1 plus 3 by n and so on. Last term is 1 plus n by n. Logarithm of this product is equal to, take logarithms in the RHS, it is log k. We know that logarithm of a product is sum of the logarithms. So I will write it as limit n tends to 1 by n, limit n tends to infinity 1 by n into log 1 plus 1 by n plus log 1 plus 2 by n plus log 1 plus 3 by n and so on, log 1 plus n by n is equal to log k. Okay, write this in the form of sigma. Limit n tends to infinity 1 by n sigma, what is the general term? Log 1 plus r by n. R varies from 1 to n if you observe the series, is equal to log k. Now converting to definite integral, you will get integral log 1 plus x dx, replacing r by n by x. Then what are the limits of x? Divide the limits of r by n, you will get 0 to 1 is equal to log k. Now integrating by parts, you can calculate the value of this integral, okay. Then you will get the value of log k. From the value of log k, you calculate the value of k. If you integrate by parts and substitute the limits, you will get 2 log 2 minus 1. The integration part you complete. Then what is the value of k? You can write this as log 4. 2 log 2 is log 4 and 1 can be written as log e. Log 4 minus log e will be log 4 by e. Therefore, what is the value of k? 4 by e. Okay. So with this we have completed the definite integral as the limit of a sum, that subtopic. So that's all for today. We are going to discuss reduction for method in the further classes in next week. Okay. Until then, bye bye.